All right, it's time to get ready for our Unit 4 test. And so for this first one, we're multiplying polynomials. So I'm going to multiply the 7x to everything on the other side and the 2 to everything, and then combine like terms. So 7x times x will be 7x squared. 7x times 1 is 7x. And then 2 times x is 2x. And then 2 times 1 is 2. And then we'll combine like terms in the middle. So 7x squared, 7 and 2 make 9x plus 2. And that's my answer right there. I'm not going to check all of them, but if you wanted to check these in the calculator, I've already put this in my calculator. In y1, I put in the original factored form. In y2, I put in my answer. And if I got it correct, it should be the exact same graph. So there's my y1, there's my y2, it overlapped. So we got it correct. I could also go into my table and check all these points are the same, so we have it correct. Number 2, x minus 9 squared means there's 2 of them. So it's the same thing as x minus 9 times x minus 9. And we're going to multiply this x to everything, the negative 9 to everything. So x squared minus 9x, and plus 81. Negative 9 makes negative 18x, and so there's my answer. Number 3, I'm going to multiply the x to both terms, the 2 to both terms. So x times x is x squared. X times negative 2 is negative 2x. 2 times x is positive 2x, and 2 times negative 2 is negative 4. When I combine like terms, they cancel out, where I'm left with x squared minus 4. Again, there's 2 of them, so 5x plus 1 times 5x plus 1. And so 5x times 5x is 25x squared. 5x times 1 is 5x. 1 times 5x is 5x. 1 times 1 is 1. So 25x squared plus 10x plus 1. All right, number 5. Now we're going to be factoring. We're not solving. There's no equals. And so we're just factoring on this one. And so for this, we've got 3 terms. So I'm going to go into my x method. There's no GCF. And so I'm going to multiply to negative 15 and add to negative 2. So to multiply to 15, I could do 15 and 1, 5 and 3, and those are my only options. The only thing that's going to work is 5 and 3. One's going to be positive, one negative. To add to negative 2, that's going to be a negative over here. So negative 5 times 3 is negative 15. Negative 5 plus 3 is negative 2. We'll divide by my a of 1 to get x minus 5 and x plus 3. Again, I'm not going to check every one of them, but if you wanted to check this in the calculator, in y1 I'll put in the original x squared minus 2x minus 15, and then in y2 I'll put in my new one, x minus 5 and x plus 3. And when I graph it, it should be the same graph. And if I go to the table, it should be the same table. And so we got this one correct. Number 6, I see all of these are even, so I can definitely divide by 2. So I'm going to take out a 2, and I'm left with 6x squared minus 13x minus 5. I can't take anything else, so now we're going to go into x. On top is 6 times negative 5, which is negative 30. On bottom is negative 13. To multiply to negative 30 and add to negative 15, it's going to be negative 15 and 2. I divide by my a of 6, and so this simplifies to be 1 over 3. And this one, if you divide by 3, is going to be negative 5 over 2. Put the GCF in the front, 2x minus 5, and 3x plus 1. Number 7, there's no GCF, and so 2 times negative 3 is negative 6 on top, 1 on bottom, which is going to be 3 and negative 2. We'll divide by the 2. And so we have 2x plus 3 and x minus 1. I can divide all these by 3, so I'm going to take out a 3. I'm left with 3x squared minus 2x minus 5. And so on top is going to be 3 times negative 5, which is negative 15. On bottom is going to be negative 2, which is very similar to the one we did over here. So it's going to be the same numbers, negative 5 and positive 3. But this one we're going to divide by 3, which is my a. So the 3 is going to go in front, then I have 3x minus 5 and x plus 1. All right, moving on, number 9. Multiplies the 9, adds a negative 6. It's going to be negative 3 and negative 3. So x minus 3 times x minus 3. Or you could write x minus 3 squared. Both are the same thing. And lastly, number 10, I've got 7 times 3, which is 21, negative 22 on bottom. And so to multiply there, I'm going to have 21 and 1. They're both going to be negative. We're dividing by 7, so that's going to be negative 3 over 1. So x minus 3 and 7x minus 1. I forgot to box these. All right. Number 11, we'll continue factoring GCF. I'm going to pull out a 3x from both of these. And when I take out that 3x, I'd be left with 4x minus 1. And I can't go further than that. On this one, I can take out a 3, x squared minus, that's going to be 16. And then that's going to be difference of squares, so x plus 4 and x minus 4. Because the square root of x squared is x, the square root of 16 is 4. That's the difference of squares. On this one, we're going to multiply to 30 and add to negative 17, so negative 15 and negative 2. We're going to divide by 15, which is my a. So we're going to have x minus 1 and 15x minus 2. And then this is 2 terms, there's no GCF. It's going to go straight into difference of squares. The square root of that is going to be 12x. Square root of that is 9. 12x plus 9, 12x minus 9. All right. Now we're going to solve the equations by factoring. So now we are going to go one step further. We do want to make sure it's an ax squared plus bx plus c equals 0 form. So on this one, I'm going to move these over here to get my a positive. So x squared plus 6x plus 8 equals 0. That's moving everything to the left side. And then I'm going to have multiplies to 8, adds to 6, which would be 4 and 2. So x plus 4, x plus 2 equals 0. If you set each piece equal to 0, if x plus 4 equals 0, I'm going to subtract 4 to get x equals negative 4. Subtract 2, x equals negative 2. On this one, I'll move these over. So 3x squared minus 16x minus 12 equals 0. There's no GCF. And so we're going to think what multiplies to negative 36 and adds to negative 16. That's going to be negative 18 and positive 2. So x minus 6 and 3x plus 2 is equal to 0. So for this first one, if you set that equal to 0, that's going to be 6. For the second one, if I set that equal to 0, I'm going to subtract 2 over, 3x equals negative 2, and then divide by 3, so x equals negative 2/3. I didn't check these, but if I wanted to check these, I could take these, and we're just going to plug these into the original to see if it works. So the left side should equal the right side. And so I'm going to do this thing where I store the number n. So I'm going to press my first one 6 and then store x. And so now my x is 6 until I change it. So for the left side, I have 3x squared. I have 108. On the right side, I have 16x plus 12, 108. 6 checks. For the negative 2/3, I'll now put in negative 2 divided by 3 and store that in for x. So now x is negative 2/3. So 3x squared is that. 16x plus 12 is the same thing. That checks too. And so that's an easy way to check it in your calculator. Number 17, I'll move the 6x over. So 2x squared minus 6x equals 0. We'll take out a 2x and we're left with x minus 3. And so if I set each piece equal to 0, x would equal 0 or 3. So 4x squared, I'm going to move that x over, which is actually going to cancel out. Minus 9 equals 0. And so now we'll difference of squares, 2x plus 3 and 2x minus 3 equals 0. And so for this one, you would subtract 3 and then divide by 2, so negative 3 over 2. Same thing over here, we would add 3 over and then divide by 2, so it's positive 3 over 2. All right, and then number 19, we're going to do quadratic formula, which has a reminder. That's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so I need to get it equal to 0 first. So 2x squared plus 3x minus 5 is equal to 0. So my A is 2, my B is 3, my C is negative 5. We're going to plug them into this formula. So negative 3 plus or minus the square root of 3 squared is 9 minus 4 times 2 times negative 5 all over 2 times 2. And if I'm going too fast, be sure you can pause it, slow it down, whatever you need to do. But make sure catch up with where I am. Now I'm going to put this box in my calculator, or you can do it mentally, either way. But in your calculator, I'm not going to do the square root. I'm just going to do 9 minus 4 times 2 times negative 5, 49. All right, so we know the square root of 49, so now we're going to branch it with the plus and minus. So negative 3 plus the square root of 49 is 7 over 4. Negative 3 minus 7 over 4. So negative 3 plus 7 is 4 over 4, which is 1. Negative 3 minus 7 is negative 10 over 4, which is negative 5 over 2. And again, you could check these in the calculator by plugging them in and seeing if they work. So for instance, I would plug in 1 stored in for x, and I would do 2x squared plus 3x, and I would see, does it equal 5? Yes, it does. And then I would do the same thing with negative 5 halves. Negative 5 divided by 2, store that in for x. And I would do the same thing, 2x squared plus 3x. And does it equal 5? Yes, it does. This one's already in order, and so negative b is going to be positive 6 plus or minus the square root of 36, because negative 6 squared is positive 36, minus 4 times 1 times 3, all over 2 times 1. So it's going to be 6 plus or minus the square root of, I'm going to put that in the calculator again, so 36 minus 4 times 1 times 3, which is 24, all over 2. I don't know the square root of 24, so instead of doing decimals, we're going to come out to the side and simplify the square root. So 2 times 12 with 2 times 6, 2 times 3. So these two go on the outside, these go back on the inside. So 6 plus or minus 2, square root of 2 times 3 is 6, all over 2. And then we'll simplify these circles right here to get 3 plus or minus square root of 6. Number 21, we're going to have, again, it's in order, so negative 8 plus or minus square root 8 squared is 64 minus 4 times 1 times 17, all over 2 times 1. So 64 minus 4 times 17 is negative 4. Because it's negative under the radical, for right now, the answer is no real solution. And then lastly, we need to move those over. So 25x squared minus 20x minus 6 equals 0. So that's to be positive 20 plus or minus the square root of 20 squared is 400 minus 4 times 25 times negative 6 all over 2 times 25. And so 400 minus 4 times 25 times negative 6, 20 plus or minus the square root of 1,000 all over 50. So that's going to be, when I branch it, the square root of 1,000 is not a perfect square, so I'm not going to branch it. Whoops. And so I'm going to come out to the side. And we're going to make quite a tree right here. So 2 and 500, 2 and 250, 2 and 125. That's not divisible by 2 anymore, so we'll do 5 and 4. Sorry, what am I thinking? 5 and 20, which would be 5 and 4. Make sure I'm doing that right. 2 and 500, 2 and 250, 2 and 125, 5 and 25, which would be 5 and 5. I knew something didn't look right. All right. Sorry, that's an error right there. I'll rewrite it a little bit neater over here. So 1,000 went down to 2 and 500, which went down to 2 and 250, which went down to 2 and 125, which went down to 5 and 25, which went down to 5 and 5. So we got a pair of 2s, a pair of 5s, and we have a 2 and a 5 left over. So 20 plus or minus 2 and 5 together make 10. 2 times 5 is 10. Square root of 2 and 5 again make 10 over 50. If you wanted to make sure that you got the same thing, square root of 1,000 is there. 10 square root of 10 is also the same thing. So we simplified it correctly, and then we can just simplify these circles. We can divide all of them by 10, and so it's going to be 2 plus or minus square root of 10 over 5. And that's my answer. And again, if you wanted to check this answer, this one's kind of a more in-depth one, so it's a good one to check. I could put that in the calculator. I'll use my fraction feature, 2 plus square root of 10 over 5, and store that in for x. Whoops. And try that again. 2 plus square root of 10 over 5, and store it in for x. And then we'll plug in the formula. So 25x squared and 20x plus 6. They should be the same thing, which they are. And then I could do the same thing. I could copy and paste this down and change this to a minus. And then put in the same equation, 25x squared, 20x plus 6. They equal the same thing. We got the answer correct. All right, and that's it for this review. Let me know if you have any questions.